Cloud providers are reporting this massive 15% to 50% spike in AI inference workloads. You spend $10 billion on a theoretical supercomputer brain, then suddenly you feel like you are trying to assemble IKEA furniture without the manual the second you try to make it actually run a basic application on your phone. We are mapping Nokia's aggressive strategy to build the physical plumbing for the AI era. The objective is decoding how their partnerships with Blaze and Nvidia intend to solve this deployment bottleneck.
Market demand pivoted violently from mere model training to actual inference. Organizations are staring at astronomical hardware bills, demanding financial returns from their infrastructure.
They basically want actual results today.
They demand immediate returns. The initial panic buying of hardware gave way to a massive deployment bottleneck. Running these models requires vastly different architecture than training them.
Nokia and Blaze are developing a pre-integrated hybrid AI architecture specifically for the Asia-Pacific region. Enterprises attempting to stitch together bare silicon, software frameworks, security protocols, and networking hardware are essentially buying a luxury car delivered entirely in loose parts,
expecting it to win a street race on day one. Edge computing AI workloads simply cannot be justified by GPU power budgets alone. Running advanced models at the local network level requires massive cooling and energy resources that a standard server rack lacks.
The geographical divide across the APAC region exposes two completely contrasting deployment realities.
Developed markets like Singapore are forcing advanced cloud-native edge architectures. Fast-growing nations like India and Vietnam are running bare-bones early deployment models while they test the physical limits of their power grids.
Nvidia actually threw a staggering $1 billion investment into Nokia for a mere 2.9% stake back in October 2025. That massive premium operates as a blunt instrument to force their specific hardware integration onto the telecom grid.
Telecom operators spent years panicking at the massive financial cost and energy drain of slapping traditional GPUs directly onto cell towers.
Oh, wow.
Nokia's AnyRAN software prevents tower meltdowns by acting as a universal translator. It decouples the proprietary telecom baseband hardware from the software layer.
Orange is testing this resulting AI RAN technology across legacy networks in European and African markets.
Standard commercial servers running Nvidia's Arc Pro system can literally handle complex AI models without destroying the local power grid. This virtualization drops deployment costs significantly. They're actively fighting off fierce competition from Intel's Xeon 6 setups, currently utilized by rivals like Ericsson.
The long-term architectural goal revolves around maximizing spectral efficiency in the upper 6 GHz band. Telecom companies are trying to pack exponentially more data into the exact same invisible radio lanes.
Operators are tearing out static physical infrastructure and replacing it with programmable compute resources.
This software-defined migration builds the necessary foundation for 6G networks.
Artificial intelligence integrated directly into the radio layer drastically improves scheduling algorithms and power optimization. The network dynamically routes traffic based on real-time usage instead of preset limitations.
Wait, really?
The cellular infrastructure physically senses the surrounding environment by detecting minute radio wave fluctuations bouncing off objects and people. Every single physical movement alters the signal.
If artificial intelligence is integrated directly into the radio waves bouncing around your living room right now, optimizing power and physically sensing your environment, at what point does your cellular network stop being a basic utility pipe and become a cognitive planetary nervous system? Goodbye.